Okay, um, so I have done a bit of stuff since the last episode. Whoa. Yawn. Okay, I have done some stuff, and I'm going to explain what I did. It's mostly with the APIs. I did 2 programs as well since the last episode, which I'm going to explain real quick. So if I list this, you'll notice many things, but one thing you'll notice is an open program, and there is a edit program now. So if we edit the edit program, actually let's start with the open program. Edit the open program. You'll notice first, so I'm going to go through this, but it basically does the same thing as the edit. Actually, I'm not going to go through it right now, but if you look at this, you may understand it. But it basically runs the normal edit program for editing things, but it loads the taskbar once it's done, so that when I exit real quick, the taskbar is still there. And then the edit program, I had trouble with having the edit a program named edit run the edit program for a reason that I have not been able to figure out. So the open program is what runs the edit program. So yeah. Actually, wait a minute. I think I know why. Not delete. Rename edit tide. Rename open edit tide. Works, okay? Edit works. So, okay, I figured it out. I can delete tide. If you didn't realize, tide is edit backwards. Alright. Clear program, I've not rewritten a clear program, so that still clears that. But, so, yep. So, edit, and because it's a separate program, it doesn't have the thing where, see how I can automatically edit with my side arrow, my right arrow? It used to be able to do that with the names of the programs. It doesn't do that anymore. So actually, I'm not going to edit it in the game. So I added something to the clock API, which I'm going to show you in text edit here. So, what I'm spelling. First of all, I put the months, instead of making it be a local table, I made it a non-local table, which gets declared when the API is loaded. So, you can access the months table from anywhere. And now, the time function. I changed quite a bit. It's this, and I don't use the string.sub anymore. I do use string.length a little bit, but I mostly don't use the string API at all. And I'm using math now, because this os.time returns a decimal number, which I turned into a string, and then did a bunch of string.subs on it, which is what I was doing last episode. But it's actually easier if you do some math to it, which is what I'm going to end up doing. So the time API might be probably, one of the simpler APIs. The month API is probably the most complex. The year API is probably the simplest. Then either time or day, and month is definitely the most complex and the longest API or function that I put in this API. But let's get right onto it. So the time API only has one parameter, which is 24-hour. Do you want 24-hour time or 12-hour time? And so that's simple. This variable here represents PM/AM. If it's nil if it's neither, it's PM or AM if it's PM or AM. And then we also have time is os.time. So if it's not 24-hour time, meaning if this was returned, if they said false, don't make it 24-hour time, then if time, so time returns a decimal number, And the whole number part, the part that's a whole number, so like 12 dot whatever, is what it returns, for example, would be 12 o'clock with whatever minutes. So what we do is if it's greater than 12, then it's clearly PM, because it has to be somewhere between 1 to 24 hours, or 13 to 24 in 12-hour time, also known as 1 to 12 in 12-hour time. So if it's greater than 12, it's PM. It's greater than or equal to 12, sorry, because noon is PM, generally. And then if it is smaller than that, then 12, which is 0, which would be 12 a.m., to 11, which would be 11 a.m., then it's clearly AM. But if they said it was 24-hour time, don't do anything special. Or sorry, I missed this part. If time is greater than or equal to 13, then time equals time minus 12. So we just, if it is PM, we remove 12 hours from it, so that if it was 13 o'clock, now it becomes 1 o'clock. So we can do math easier. And if it's 24-hour time, we don't do anything to time or stod. So this stays nil, and this stays 13 hours or 24 hours or whatever, right? So that's handling the difference between 24-hour time and 12-hour time. Now it's all the same. We're just trying to turn this decimal number into hours and minutes and returning that number. All the same. Doesn't matter anymore. So local hour equals toString math.floor time. So I want to return these as strings, because if we go back to Minecraft here, you'll notice it says 07, and it would say 09, for example, if it was 9 minutes. I want it to stay like that when it returns to the program, or when the API returns the number. I want it to return 07 or 09 or whatever, and you can't do that. If it's a number, it's going to delete that 0 automatically. So it has to be a string if you're going to have a 0 there. So I have it returning, I have the hours and minutes in strings. So that's why I have it toString. What this math.floor means is, so if we have, say, like 12.300, so that's our time, right? When we floor it, we round it down to the whole nearest whole number. Or round it down to the whole number. So that just becomes 12. That's what hour is, because hour is this part here. Hour is this 12, so it's 12 o'clock, if this is what os.time returns. So we know it's 12 o'clock. And now minute is, and then this turns into a string, so it goes like that, right? So minute is math.floor time minus two-number hour. So it floors, or times 60. So if we get a calculator, I'm going to do this on calculator. So first thing, so it gets time, which let's just say is 12.3 minus two-number hour, because remember we set hour to a string. So minus hour. So in this case, hour will be 12. So now we have 0.3. Floor that, so 0 times 60, which is 0. Wait a minute, what? Because it's a decimal. And then if we floor that decimal, then it's always going to become 0. So why do I have this? Oh, the 60's inside the floor. Okay. Now that makes more sense. So we still have our 0.3. Before we floor it, we multiply this by 60. So now it becomes 18. So, basically, so 0.3 would be 18. Um, so it's as if we had 3 times 6 is 18 too, right? Because I added a 0 to the end of the 6, meaning that we have to move the decimal back 1. So if we move the decimal back 1 and remove that 0 from the 60, then we have 3 and 6. But say it was 25, right? Well, that would, so 0.25 times 60 would give you 15. Right? Yeah. So, because this can go from 100, so it can go from anywhere from 0, 0, to 1, 0, 0, 1, 0, to, or not 1, 0, 9, 9. Anywhere from 0, 0 to 9, 9, which is not the spectrum we want. We want it to stay within the 60. So, what we have to do to keep it within 60 here, to keep the 60, or to keep it within, because there's only 60 minutes, right? So the max it can have is 60. So if it was 99 times, oh wait, no, it would be 0.99 times 60 gives you 59.4, which then it floors into 59. If you ever get a decimal, it will floor it, basically cut off the decimal. So then it gives you 59, and that's exactly the 1 minute before, exactly 1 minute before it becomes 0, which is the next number you'd get in your thing. And 0 times 60 is just 0. So then you floor that, and you get 0. So multiplying it by 60 it guarantees that your number after flooring it will be an actual number below 60. Basically, if that makes any sense. And then we do a little bit of just delete. We do a little bit of handling here to add that 0 in front, so it's always a double digit. We just go if string.length, which is the length, so you get the length of the string. If the length of minute is 1, meaning there's only one number there, then just put a 0 in front of it. Put 0, minute equals 0 minute. So say minute was 1, then it becomes 0, 1. Same thing to hour. And then if stod, which remember we set to nil up above, meaning it would be false. If it was nil, it's false. If it's anything else, it's true, basically. So if not nil, kind of. So, no, if this has a value, that's what that means. If this has a value, nil is considered like no value. So if this has a value, then return hour, minute, stod, which means it would return the hour, the minute, and then either AM or PM, because that's the only way it could have a value, is if we gave it one earlier. And if it doesn't have a value, then just return the hour and the minute, which means we never gave it a value, meaning that was 24-hour time. So if that made any sense, great. If it didn't, look at this. Try to learn all the different functions if you don't already know them. Go through it yourself. See if you can break it down on your own. So now we're going to go to the year function, which is really just this little block here. It's very small and simple. So we had finished this before, but I decided I kind of cheaped out and I use 365.25 for a year. I wanted to actually have it tell the year with leap years involved. So obviously I had to get the number of days, so I did os.day. I don't know why that's indented. It's just one line of math here. Just setting a bunch of things, or actually, there's a bit of math. But this is like these 3 things of math. I forget what this is called, but I'll explain in a second. Not leap year days, so days that are not inside of a leap year, or that are not involved in a leap year. So I did the math here. If I close my calculator. So 365 times 4 will give us the number of years for a leap year. And then you also need to add that 1 extra day you get every 4 years. So every 4 years we have this many days, which you may notice is the same number we have there. So this means, so let's say days was 1,462. We just divide 1,462 by 1,461, which, if you remember, when you first started doing division, you would go 1, and then you'd say, with a rest of 1, like, you'd say this divided by no, I can't remember what my shortcut is for that, so let's do this. Divided by that number equals 1 with a rest of 1. That's what you'd write when you were very, very little and you were first learning division, right? You wouldn't use decimals, you'd just say with a rest of 1. Like, I can't divide this one number, so I'm just going to say 1 with a rest of 1. What this thing does here is it gives you it returns the value of whatever your rest was. So in this case, it will return 1 for not leap year days. So basically, it cancels out all the days not involved in a section of leap years. So if we'd gone 4 years and 1 day, it would return 1, because we yeah. So I'm not sure if that makes sense, but I hope it does. If it doesn't, I don't know, try to figure out this math on your own. If it does, keep listening to me. If it doesn't, skip over this function. I feel like I'm not going to explain this function very well, but hopefully it makes as much sense as I can make it. But year equals days minus not leap year days. So basically, this is, so this would be the number of days throughout. So once a leap year arrives, that would add 160. So we got our factorial, or our, was that factorial? No, it's not factorial. No, factorial is something, it's the exclamation mark. Never mind. So we got 1 from this. No, I feel like I did this overly complicated. Wait a minute, give me a second. If I delete this, just divide days, floor days divided by 1,461, give me the same thing, right? I don't know, if this works, I'm going to leave it like that, but I'm pretty sure you could simplify that a little bit. But, so we have days was our 160, or 1,462, minus our not leap year days, which we got 1 for that, right? So that gives years, or year, it always gives year an exact amount of 1,461. I could just do days divided by this times 100 floor days divided by that times, never mind. Okay, never mind. So now years, which is what we're going to be doing our last flooring on. Years equals days divided by 161. So that would give us a whole bunch of numbers, times 4. So, if, let's say that we had exactly 4 leap years. So it's 1 6, or it's 1461, right? And I just sat on the mouse. Let's unplug that for a bit. Okay. So let's say it's, oh, I'm in month. Oops. Okay, so let's say that our days is 1,461. So then days, we've already subtracted the not leap year days. So days is exactly divisible by 1,461. And that will give us the number of years that have passed. So let's say we have, this is our second leap year. Exactly, yeah. So we'd have this giant number is our days. We divide that by 1,461, and it gives us 2 leap years. That's how many leap years have passed. And so what we need to do is, if 2 leap years have passed, since every 4 years is a leap year, we just multiply that by 4. Multiply by 4, we'll get 8, which is the number of leap years we've had. And then, why do I have plus a year there? Oh, this is to figure out years that are not leap years. So that's what this was up here. Now I remember. So days minus not leap years means so let's say we had 1,462 times 2. So we've had 8 years, second day. No, let's say we had 9 years. So we've had 9 years. So far we have 8. Now we just need to add that year. And it's the second day. So you already know not leap years is equal to days divided by 1,461. Or the rest of 164 divided by 1,641. So if we divide by 1,461, we have 2 with a rest of 367. So we have a rest of 367. So that's what not leap year days is equal to. Or a remainder, sorry, not a rest. A remainder of 367. So days minus 367. So we know days was plus 1,461 plus 1,461. So this is days minus 367. Wait. That's not right. I'll give you all the leap year days. That's not what I want. Wait a minute. This is not what I want. Adding